Solve. If a system's equations are dependent or there is no solution, state this. 2x plus 2y equals 0. 4x plus 4z equals 4. 2x plus y plus z equals 2. Well, first of all, let's look at this equation and realize that we can simplify it by dividing both sides by 2 with the result x plus y equals 0. And in this equation, we can divide both sides by 4 with the result x plus z equals 1. Now, part of the reason I did that is it's obviously easier to deal with those equations than these. But also now what I want to point out is this equation involves x, y, and z. Well, what we can do is over here, we can solve for y in terms of x and substitute it here. And here, we can solve for z in terms of x and substitute it there. That'll give me one equation with just x as the variable, and then we'll solve for x. So, with this equation, I say y is equal to negative x. With this equation, we say that z is equal to 1 minus x. And now I make the substitutions. I have 2x plus y. Well, y is negative x. Plus z. Z is 1 minus x. And that's equal to 2. Well, now I have 2x minus x plus 1 minus x equals 2. 2x minus x is 1x. Minus another x is no x. Look what happens. We have 1 equals 2. Now, sometimes that may mean you've made an error, but I've done my math correctly. 1 does not equal 2. This is a false statement. And that means this system of equations has no solution.